to present, Pedro?
Sorry?
If you want to present.
Christian, can you present?
Sure, let me search for the link to open it. Is it visible, the one with the presentation?
Yes.
Yes.
Yep. Okay, just 1 second. I want to make sure. Yeah. Okay. So
Yes, I think I'm going to start. Hello, people. We're going to talk about Apache Kafka. So I think this is the only presentation who will have for people. Thank you for hosting me, Paul, Pedro, Christian. So, okay, could you move to the next slide? Okay, so I'm going to start with a fancy definition about what it is Apache Kafka. So just for the master purposes. So yeah, Apache Kafka is an open source distributed even streaming platform used by thousands of companies for high performance. So this is to start, this is a very dramatic the definitions, but let's I'm going to give another definitions. Can we move to the next presentation? Okay, so here we have a video. I'm not going to reproduce that. This is just a screenshot of the video that explains in a big manner what is Apache Kafka. But two key points that I want to mention is that in the traditional database, Kafka, in the traditional database, we need to think on things. Every object in the real world, when we want to move it to database, we think as things. And in the database, we save the state of those things. So every time, let's say, a football soccer match, we save the users, we save the players, we save the match, and we save the state of those entities. But in Apache Kafka, we need to think in events. So event first and things are seconds. And Kafka is basically an ordered collection of events, and these events are called logs. And the definition is that Kafka is a system for managing those logs. So this is basically what Kafka is. But to give more context, I want to talk about the history of Apache Kafka. So can we move to the next slide, please? Okay, so Jay Krebs is the founder or the creator of Kafka. And Kafka was created in LinkedIn, in the platform that we all know. So this was created in almost 2007. And when Jay Krebs was at LinkedIn, he discovered that there were a lot of issues with their application, with their environments, because her growing user base was creating a lot of conflicts on their platforms. And also all their data systems were running on one single server. So we can see that LinkedIn at the time doesn't have a good architecture to the applications. So yeah, since the data systems was running on a single server, the first thing that they do was to buy bigger and bigger machines, which means a vertical scale. So they spend a lot of money trying to yeah, to meet the requirements and try to support all the requests that they were receiving. But they realized that the vertical scale was not enough, and it was the solution for the problems. So they realized that they have to move to a horizontal scale, which means transition to a distributed data systems. So they start to work on this horizontal scale. Can we move to the next, please? And they start to work in a, they start to work with new technologies, and they start to implement Hadoop for their data warehouse, and they build a distributed key value store for the data layer. So this new architecture will allow them to move to the horizontal scale. But these transitions, as they mentioned, was powerful and painful. Powerful because with this new ability to implement arbitrary amount of computational power, that means they were able to query all the information they will have at the time. That allowed them to create cool products, and that makes to grow the business. And they realized that the systems were valuable only if their data was fresh and accurate. They already possess a lot of amount of data, but that wasn't enough. They need that data was fresh and was accurate. Let's say real time. So can we move to the next, please? So then they start to work on this new transition to this vertical scaling, and also realize that their data, or the data that they were managing, was a mess. Why? Because, for example, their data warehouse, when they have to build all that information, all the information that they were managing, there wasn't a standard for that data, so they had to collect the data from a wide from various places, and the data was in different formats. So there wasn't a standard to collect all the data. So also realize that when they collect all the data, there's a common practice to use the batch processing. So for this process, you know that the batch process usually it's once a day, and usually is at night. So with all of these problems that that there are no a standard for collect the data, there are not just one place to collect the data, and all this collection should be in just in a batch processing, and just once a day. They start to work to enhance their architecture of their applications, and they create a lot of data loads for Hadoop. So with Hadoop, they try to copy all the information from any place. So at the end, they were like in the process to be able to manage all the information that they were collecting, because we know that LinkedIn has a lot of information, not only for the users, but only for the enterprises, the connections, yeah, a lot of things. So at the end of this process, they realized that only 14% of the data that they owned, only 14% was covered with all of these efforts. So, and they realized that when we want to configure a new data source, they want to manage their data layer, that was adding a lot of complex to their existing systems. So, and at the end, they realized that also they still doesn't have real-time processing, because that wasn't one of the key points that they wanted to achieve, the real-time processing. Because yeah, we know that for example, if we have on a laptop or mobile, and if we receive an email, that email is received in both devices in real time. So this is one of the concerns, because how it is possible that I can receive an email in real time, but I am unable to process all this data, and I am unable to present this information to my consumers. So yeah, they keep working. Can we move to the next, please? And they think that maybe the solution for their problems was already exist, but they were ignoring the solution. So they start to investigate frameworks, systems, applications, any solution that was out there. But at the end, they decided that no application were going to meet their expectations. So they decided to create not Kafka, but a solution for their problems. But they have in mind three principal aspects for one behavior. The first is that they want a messaging system, and the second, they wanted a solution that could support low latency that will be scalable and that will be fault tolerant. The low latency will allow the real-time processing. The scalable, because they want to support heavy amount of data, and fault tolerant because they wanted to provide information or data in without loss of data. But apart from that, they want that their solution not only were able to support these three aspects, but they also want that this application or this solution were able to copy data from place to place. And also they want that systems that already exist were able to use this solution and take advantage of this behavior and process data in real time. So with these aspects in mind, they realize that within LinkedIn has a tool that always was there, but that tool was in charge to collect the operational data, because LinkedIn not only was collecting data from users, but they also has a system that were collecting operational data. That means error logs, performance metrics, whatever was happening inside the systems, inside LinkedIn, they have another system that was logging all that information. So at the end, they realized that the solution was always there. So they take that tool and start to make them stronger and enhance that platform that they already has. So at the end, they discovered that they not only create a tool that supports their needs, but they create like a central nervous systems, because whatever was happening inside LinkedIn, that was acting like a neuron sending a message. So if a system produces an output or a message, this central nervous system or this Kafka receive that message, and that message trigger a response according to that message. So from here, I think we know the rest of the story. But yeah, Kafka was created because the need of LinkedIn to try to manage all this wide range of data sources, be able to provide real-time processing, be able to scale that information, and yeah, can we move to the next slide? Yeah. So in 2014, Kafka was donated to the Apache Foundation, and apart from that, Apache was improving this system. So in the picture we have in the middle we have Jay Cripps, who is the founder, Also, we have a John Rao and Niha Narkid. So all these three guys are the creators of Apache Kafka. So yeah, I think this is the story about Kafka. And to talk more about how this works, I think Pedro is going to talk how this Apache Kafka works.
Okay. Can we move to the, okay. Here we have the Apache Kafka architecture. As you can see, it's not a complex architecture. We have some producers here. These producers are the ones that are creating or generating the messages. These producers are pushing the messages to the Kafka cluster. This Kafka cluster is composed by brokers. But everything about these push messages are contained in something that is called a topic. A topic is some kind of like how can I say this? Like, for example, for saying something extra is something like some kind of a specific thing that you are going to be subscribers, so you want to receive something like messages. Like, for example, when you are on Spotify and you are subscribed to a podcast, that podcast will be something like a topic. Yeah, but yeah. So the brokers are here. They have like the information from the messages, and then we have Zookeeper. Zookeeper Zookeeper is another project. We can even talk about Zookeeper like in the same way that we are talking about Kafka, but in this case, Zookeeper that belongs to Hadoop is also helping Kafka to administrate the distributed system. And then we have here the consumers. Consumers are the servers or machines that are going to consume whatever is the Kafka cluster producing. And we have consumer groups, as the name saying, well, consumer groups is just a group of consumers. And well, they are going to be subscribed to a topic and they are going to get some messages from the topic. So that's like the main architecture. Now we're going to, well, in the next slide, we are going to talk about the, can you move to the next slide, please? Yeah, as you can see, they are the same names that we have in the architecture image. So can we go back? So it's easier to talk about them when we have there. Okay. So basically, as you can see, we have the producer. Like I said, the producer, well, is just a sender, is just the responsible of sending the messages and data to the cluster. A lot of producers can generate messages to different topics or even to the same Kafka topic. Then we have the consumers that are here. The consumers, well, they are the receivers, the one that are going to, like the name saying, consume whatever the cluster is going to give them. Well, then we have the brokers. The brokers is nothing, just a server. It's just like an intermediate between the consumer and the publisher and the producer. So basically, when it needs to work with the when the broker needs to work with the producer, it's going to act like a receiver, and when the broker is working with the consumer, it's going to act like a producer, someone that is giving to them some information. Then we have the cluster. The cluster, like I said, the cluster is just like a group of brokers or a group of servers, nothing like the same cluster, the same definition for cluster that we already know. And then we have well, then we have like the more important part of Kafka, that is like what I say, that is a topic. What is a topic? A topic is like just like an identifier for a group of messages. So we can know that we have, in this case, this should be like a, as you can see, the brokers are inside this the rectangle. This should be like the topic. Well, the topic, like I said, is just like how you are going to know what it's like for me, like a group of specific messages, like how you are going to know the what messages or which kind of messages are you going to receive when you are a consumer. So because remember, the Kafka is going to manage a huge quantity of messages, so you are not going to feed all the messages to all the consumers. So the consumers need to specify, hey, I just want to have messages from this kind of messages, or getting from this producer, or getting from this specific service. So the topic is some kind of identifier for those messages. And then we, like I said, Kafka is going to manage a huge quantity of messages. So we need to remember that Kafka is made for working with this. It's just like a distributed system. So sometimes if it is needed, they are going to separate the messages or the information into partitions. So Kafka partition is another part of this system, where Kafka is going to, when it's needed, is going to partition the full information so they can process the information in parallel. So they don't have like bottlenecks or some kind of those things. Then we have something that is called also offsets. The offset is just like a, well, like I said, we have topic, we have a partition. Topics is like for the general information that we're going to get. Partition is just like a dividing all that information into small parts so we can process faster and in parallel all the information. And then we have the offset. The offset is the identifier for each one of the messages, because we need to know which message is going to which partition or to which consumer. So at the end, all the information that is going to Kafka is going to have a unique name that is going to be made with the topic identifier, the partition identifier, and the offset identifier that is going to be specific for each message. And we have the consumer, well, we have the consumer groups. Well, like I previously told you, the consumer group is nothing but a group of consumers. Each consumer can be subscribed to any specific topic, or the full group of consumers can be subscribed to that specific topic. And then we have Zookeeper. Like I said, Zookeeper is like another system that can be analyzed by itself. So I'm not going to abound in this. It's just like some kind of tool that is helping Kafka to taking decisions and that kind of stuff. Can we go to the next 2 slides, please? Then how does it work? How Kafka works? Well, Kafka has 2 ways of working. One is the queuing, and the other one is like the publishing something. I don't remember. We are going to see in the next slide. But in this slide, in the queuing, good thing is that, as you can see here, the producer of any application or service sends the data to the stream. This is the data, and this is the queue. In this model, each piece of data is read just once. What is the problem? The problem is that this is not multi-subscriber. So even with the data, is going to go to all the consumers. In the queuing model, no different subscribers can access this data. So we are going to have just one consuming group that is going to consume this data, and is going to be for all the consumers. That's the QE model. Can we go to the next one? And then we have the publish subscribe. In this one, it's the piece of data is going to be read for all the subscribers. This is multi-subscriber, but as you can see, in each subscriber, just one of the consumer is going to read the data, not all of them. Sorry, And then, for example, in this case, in the first one, the subscriber is going to analyze the data, and then the subscriber is going to feed the data to the consumers in the way that they want to do it. But in the other way, just one single subscriber is going to consume the data. Can we go on to the next one? And then we have these APIs. Kafka has 4 APIs. The producer one, that is the one that is used for generating the data that is going to be part of the Kafka topic. Then we have the consumer one, the consumer API, that is the one that is going to use the consumer for being fed with the data from Kafka. Then we have the streams API. In this case, this API can make one specific stream processor, I mean application, to behave like a stream processor. And then we have the connector API. In this way, this connector helps to, like it says, seamlessly automate the addition or from another application so that to that one specific topic that is already running. And I think that's all for. Oh, can we go to the next one? Yeah, that's all from my part.
So I'll go next. In this case, I'm going to highlight some of the advantages. Pedro and Saul have already started to mention some of them, but here all together. The first one is to the high throughput. This is because without requiring a big size hardware, it can achieve high velocity and it has the capacity of high volume data and also low latency. This is because, as Pedro and Sol already mentioned, it is able to process a lot of data in just some milliseconds. And the fault tolerant part, because if a single node fails, it won't compromise the full cluster of it. So this is because of the durability that it has with all the replication behind the scenes for all the data and messages passing through the hard disk and the memory. Also with the scalability, that's another benefit, because there is no the requirement for a downtime. It can scale in or scale out on the fly. And as part of the distributed, because some of these capabilities, such as durability, scalability, allow the replication and partitioning of this system. And as Pedro mentioned in previous slides for the message broker capabilities, this is because this service can handle one message from the sender to the receiver, even if they communicate with different protocols. This can be like the intermediate part between the two of them, allowing the communication. And because of the high throughput and the low latency, this enables the high concurrency, because on how fast it reads and writes all this information. By default persistent, because some of the other capabilities that we've seen, this one comes as default as part of the messages existing and keeping even with some failures. Consumer friendly, because it allows to communicate with different languages. It supports a lot of them, and it can use like different of the most common ones for to work. And the batch handling, it is because it can work for both for streaming and for batch operation. To extract, transform, and load operations are allowed here in Kafka. It is not that only works for streaming. And as we will see later on during the presentation, there are a lot of use cases where we can rely on Kafka. A summary of all these advantages, another one will be like the real-time execution, which is crucial for some business. And that's also one of the key reasons to go with Kafka when using it. So one of the disadvantages, there is no complete set of monitoring tools. This is because, as we will see also later, one of the part of how they make money, this is like something that they sell apart from the whole system. And even though Kafka works really fast with some of the default configurations for messages, at the time that you try to customize for some of your services, this impacts really bad on the performance for Kafka. It is not that friendly on that side that when you try to create your own kind of delivery messages. Similar with the not support wildcard. Also because it is not that easy to match with the specific topics to read or to subscribe, as the example that Pedro mentioned. And also for the APIs that were presented, there is not like a quick rhythm or delivery on the updates to keep on the most recent version of the APIs, which allow the corporates to use like the most recent version of all the software. This is because that relies on some users and corporations to keep going with all the updates and enhancements on every version of new language. For the reduces performance, it is also because at the time that you start to customize your product, it will hit or impact on the default Kafka parameters, like the size of the messages. And with this, Kafka suffers because of the algorithms to compress and decompress the archives. The performance will get impacted because it is not falling into the default or expected ones inside the algorithm. And if you have like really huge messages or the worst case scenario which Kafka handles, then you will really notice at the time that you are working on it. And because of this, you will experience like this clumsy behavior or suffer from slowness on your server. Same for this lack of message paradigms, because as we saw, it is difficult to customize your messages, but once you do, it doesn't also support like all the existing one. Even some of the common ones supported by some other tools, there is not that capability here. I think that will be it. Yep.
Okay, so now I will talk about some like the main competitors from Kafka. There are like different classifications about the competitors in Kafka because like Kafka does like, it's like a monster, honestly, and it does like a lot of things. For example, some of the use cases that from Kafka could be the logging system, for example. It can be used as a logging system. It can be as an analytic system. It can be only as a streaming messaging or queuing system, and for processing later data, for example. And one of the classifications that that it has is like, for example, it compares against the, sometimes when you Google like, okay, what are the Kafka competitors? You can find like Google Cloud Pub Sub or Rabbit, Amazon SQS, Amazon SNS, and things like that. All these are actually queuing mechanism or queuing tools. And what it differentiates from the others is that usually these mechanisms, as Pedro shown, usually you have like one consumer, and when the message is consumed, the data is lost. All these messaging queues run in memory, not as Kafka that you have like persistence of data, and you can like, how you say, you can have different consumers consuming the same data. And well, Yeah, that so the main difference between the messaging queue is that it's run into memory. So versus Kafka that you can hold persistent data. Then some other, can you change the slide, please? So other competitors, like for example, are also like Apache Flume, FluentD, Amazon Kinesis, and Sentry. Those are also competitors because Kafka can be used as a logging system, as I mentioned. But for example, something that differentiates Kafka versus Apache Flume, for example, is that this mechanism, well, Apache Flume is mainly for moving information, log data between one place and the other. And also Apache Flume, it works like a push model where when you have the queue and you have consumers, you are pushing information, how you say, the data to the different consumers. But Kafka, it works as a pull model. You have the different consumer groups and consumers in those consumer groups, and they are pulling the messages from the queue. And it's specially designed for Hadoop. Then, well, FluentD, it's the same, moving data. Amazon Kinesis, you can have two types of Amazon Kinesis at least, that it's the data streaming, that it works similar as Kafka, that is for processing and storing information. And the Firehose, that it's mainly for moving data, for example, for like ETL. And but Amazon Kinesis actually is like really expensive. And then you can use also a Sentry, that it's also used mainly as a logging mechanism, that it's for error tracking, for monitoring tools, for checking, like, for example, performance or other type of metrics. You know, it's like a logging, mainly used for like logging system for later use or evaluation auditing. Then there are other tools like, for example, HubSpot, Operation Hub, Confluent, MuleSoft, Workato, AppMixer, that those are like a software as a service only. So actually they have like some of them have actually Kafka implemented behind. The main difference is that you don't have to take care about like any infrastructure or things like that. And well, usually they charge you, how you say, for the time that you are consuming like these services, right? The difference between when you are working with Kafka is that you have to manage like all the infrastructure by your own, and also you are paying all for all the services all the time that Kafka is up, right? Can you go to the next slide? So there are like more competitors, like for example, and I separate these ones as from personal experience and opinion. Those are, for example, Apache Spark, Akka, Apache Storm, and Redis. So Apache Spark, the main difference is that, well, all these four tools handle like are made for big data, for example, can be used also for logging and also for streaming messages. But the main difference, for example, for Apache Spark is that it needs one entire cluster to run, you know, and how you say, there is also like some disadvantages that it's like not type safe. And also sometimes the messaging, when consuming the messages, you can have like high latency. So sometimes the messages are not going to arrive on time. And Kafka, it's really well known because you want to, well, you try to process the messages on real time. So one of the main advantages and like from Kafka is that you have most of the messages, let's say, real time. Then Akka, one of the drawbacks is that it's written in Scala. So most of the code has to be done like in Scala. So it is more complex to use for developers, but actually it's high performant. And it's also the way that Akka was done. It's more, how you say, to be used for, well, in the business logic rather than being rather than having a separate entity to have all the messages there. So at the end, one of the, as you will see later, Akka is it's recommended to be used mainly when you have experience on the tool and you know Scala. And then Apache Storm actually was created by Twitter, and it's mainly used for data computation versus Kafka, that is like more about transferring data. And Apache Storm, one of the main difference is that it transfers all the messages directly from the input to the output. And in Kafka, what it happens is that it's storing all the logs into files that are like X3 or XFS files locally. So when you are working with Kafka, something that can happen is that you can reread logs, old logs. That is one of the key differences from other tools. And then the other one, it's Redis. Actually, Redis is like a database system where you can have also like streams. The main issue with Redis is that you have like memory usage, you know, and so you need a lot of configuration and a lot of adding a lot of logic. So you can have the same, how you say, the same behavior as Kafka. It's like one of the advantages is that you can reduce the costs. You know, you need actually less infrastructure and less maintenance. But you have, as I mentioned, like you have to add more extra, you need extra developer work at the end, you know, and application logic to have the same behavior as Kafka. Also, something that it's a drawback from Redis is that Redis is in memory. So if you have like some issue there, all the, how you say, all the messages that are in queue, they can be lost. So you have actually to add like extra logic to have persistent messages. And then, so in summary about these tools, when you want, like, for example, to have a low latency in business logic, and you without maintaining like managing other clusters, you will use Akka. And then when you want low latency messages, like that are a lot of microservices are publishing information on the same message bus, and you want persistent data and want to be able to reuse messages, then that's when you use Kafka. When you want to have like how you say, big streams of data computations, and also you want to, actually this how you say, when you want to display information with different tools, you use Spark. Also, when you don't have like if you don't care about low latency, because sometimes it can have a high latency Spark. Then when you want to reduce costs, you know, and you want a medium size of messages, you can use Redis. And if you want also like low latency processing fast information, you can use Storm. And but the drawback is that you are not having persistent in the information. Can you go to the next slide, please? So again, like, okay, when to use and when not to use Kafka. So as everybody said before me, Kafka is used when we are managing big sets of data that wants to be transferred. It's like having like an endless stream of data, an infinite queue, let's say, because you are saving all the information in hard drive. Then Kafka is being used also when you need almost like real-time processing and you don't want like high latency. Another advantage of Kafka, actually, that it was not mentioned before, is that it has a lot of compatibility with different data tools and storage systems. So all the streams can connect or have like sync options to, for example, storage systems like S3, database, data lakes like InfluxDB, Redshift, Postgres, and it connects directly to several monitoring systems like Prometheus, and then well, and it has like a lot of connectors for so many tools. So that's one of the advantage, and mainly one of the reasons is because it's open source. Then another advantage is that since you are storing all the data in hard drive, you are able to reread or replay the information. Like for example, if you have one consumer group, well, you have a lot of consumers in one consumer group, but let's say after 2 days, you create a new consumer group and you want to process again, like all the data from before, you can do that. Kafka, by default, I think that it has the 7 days of persistent storage, but that can be configured to keep the messages as long as you want. And then another one of the most important things is that the messages are processed exactly once, no matter if you have like processing, they are processed exactly once per consumer group, not per consumer. So if you have 3 consumers in one consumer group, you know that each messages is going to be processed exactly one time, not 0, no more, exactly one time. And when not to use Kafka when you are processing few data, and why not to use it? Mainly because it's expensive. So that's why there exists like a queuing mechanism, because those are like cheaper. The main difference is that one queuing mechanism is like having one stream on Kafka. So if you want to implement a lot of queuing mechanisms, probably you can use Kafka, because each stream is only one configuration, and you can have one stream usage as the equivalent of using one queuing tool like SQS, for example. Then if you want to do transformation on the fly, you don't want to use Kafka. It's mainly for I say after processing for consumers that want to process the information later, not doing transformation on the fly. Then when you are sending critical information that should not be lost, it seems that it can be, well, there are some, it can lose some messages in some ways versus other tools. And what else? And also one of the worst things about Kafka is that it's really costly, and you need an infrastructure team usually to maintain all the Kafka services. Can you go to the next one, please? So somebody is going to talk about the main customers.
Sorry, I was mute. I'm going to be a little bit faster in this point. As you can see, Kafka is like some kind of like the dominant tool in the market for the specific services. So we have a lot of companies that are using Kafka, but I just put here like the famous one. Okay. We have Pinterest, Adidas, Airbnb, Coursera, Cisco, LinkedIn, but how they are going to implement, how they are using Kafka. You can, Paul already said, Kafka can be used like in a different ways, right? So, for example, Pinterest uses the API that I say, the Kafka Experience API, the one that allows you like streaming all the data that you even if you have the data like in a batch way. Pinterest use that information to for some predicted budgeting that they already have, and also all that information that they are using is like filling the machine learning projects that they are using, so they can predict things that you want to see in your next in the next time that you want you are accessing Pinterest. Airbnb use Kafka for one pipeline that they have like there is an event pipeline and some exceptions trackings. Then Netflix, they are using real-time monitoring and event processing pipelines also for them. Mozilla right now, they haven't implemented Kafka right now, but they want to implement Kafka for replacing some production system that they are in charge of collecting some performance and usage data. Then we have also PayPal. PayPal use Kafka like part of the something that I call Couchbase agent, so they can push some messages to Kafka. Well, we cannot forget LinkedIn. They are the first company that started using Kafka. They mostly use Kafka for stream data and some operational metrics. This information from Kafka as they are feeding something that is called LinkedIn Newsfeed and the LinkedIn Today. And well, there are also Oracle, PayPal, Spotify, Twitter. Twitter, like Paul said, Twitter already has a Storm. So in this case, Kafka is part of the infrastructure that is using a Storm for the streaming processing. And that's all from my part. Can you go to the next slide?
Okay, so these are part of how they make money. So as you can see, they went open source on June 2011. So Kafka is free to use, but there is this Confluent company, which are the one that created Kafka, as we saw in the history. So they're the ones that gives the support to Kafka. They also sell some of the trainings, and as we saw, there are some open source monitoring tools, but by itself, Kafka doesn't have like the best ones by default. So they can also help with that if you want. So by some exchange of money. So basically that will be it, like providing like the full support package on how they make money to keep this process.
Okay, I just want to add something a little bit this. You can say why Confluent is making profit from Kafka. Well, the real thing is that Confluent, besides all the things that they are doing, they are the ones that are injecting most of the code to Kafka. They are the ones that are solving issues. They are the ones that are generating new features or new stuff for Kafka. So that's the reason that even when Kafka is not doing money by itself, Confluent is making some profit because of Kafka, because they are the experts on that part.
Yeah, so actually the CEO is one of the creators, right, of Kafka.
Yeah.
And also another thing is that Confluent, probably I think that is the most widely used because it has a lot of connectors and tooling already implemented there, you know. So you can like connect with almost everything and almost any database and things like that. As we mentioned, like there are some, how you say, Kafka is widely used, well, and it has offers a lot of options with connectivity. And what Confluent does is like they are developing like all that the functionality, and they are adding it there in their software as a service, right, platform.
Okay. So
yeah, and yeah, just one last thing about this: the money. Since they are open source, they are looking well when Kafka becomes or was transferred to Apache, they look for some investors, and at the time they collect 6.9 millions to finance they call it this new adventure or the new adventure, but yeah, they try to get support from some investors.
Okay. So the next, I think that's all.
Yeah.
Yeah,
so
that's all.
For now, it's only that, well, Q&A answer question.
Yeah.
We didn't add that slide, but I don't know if anybody has like any questions about this, like about the usage, about the history, about like the competitors, like about anything.
Hello, yeah, I have a question. It's because I am a little bit confused because in some part of the presentation I was thinking that Hadoop was a competence from Kafka, but no. Hadoop and Kafka means they are complementary products, or well, I understand that after a while. But I would like to know from you guys, which is the difference between Hadoop and from Kafka? I understand both are used to handle a lot of amount of data. But I would like to know from you the differences or what you think about the difference between Hadoop and Kafka.
Well, I don't know about Hadoop because I haven't used Hadoop. But what I can see is that there are some things that Hadoop is using. I think Hadoop is like a big project, and maybe, well, for being honest, I don't know almost nothing about Hadoop. I don't know if anyone in my team knows something about Hadoop.
I'm also does not know much about Hadoop, but what I can understand about this confusion, because yeah, at the beginning I mentioned Hadoop, but Hadoop is like a storage system.
Oh, okay.
So that's it. In LinkedIn, use Hadoop to transition to a horizontal scale of the data they has. So that's it. It's a storage system that allow LinkedIn to manage the data that they were storage. But yeah, as we mentioned, Kafka is more like the transfer of data. It's a message. It's an event-driven mechanism. Store logs. Yeah, it's not related with the storage per se. It's most like how the data is transferred.
Okay, understand. Yeah, it's a pretty good point. Hadoop kind of storage, and well, Kafka to transfer all that. That's a good point. Thank you. Thank you, Tim.
Okay, I don't know if anybody has more questions.
You mentioned a lot of companies. I didn't see name of Facebook or Meta there. Any idea about?
I didn't take that companies from any part, but from the Apache powered by page. So I think I didn't see Facebook or Meta there.
No, I mean, considering Facebook I imagine Facebook would work similar with LinkedIn, not much different. So I was just wondering what would be the thing that they are using. I mean, do you have to, it's just out of the basically the context, but I don't know if any one of you have any idea.
No, not really.
No, actually, I don't. Yeah, me too. Like from the main page from Kafka, we can know, like, for example, what are the companies, but we didn't look around the other way, right? Like, okay, Netflix, what does Netflix use versus the other ones, right?
Mm-hmm. And I saw the name of Adidas there. That was like
Adidas is there.
Like a black sheep there. What they do with Kafka? I mean, any idea? Yeah.
They have like this platform that is called data streaming, fast data streaming platform, and they integrate sources systems. As you can see there, real-time event processing. Most of the companies, as you can see, they are more into the processing of the events and monitoring, and some of them are getting analytics.
No, cool.
Yeah. Yeah, a lot of companies. I mean, those are some big companies, but not even those companies are using Kafka. I mean, there are a lot of the small companies that are using Kafka, but well, they don't have the spotlight for being there.
Mhm. Any other question from student? No? Okay. Okay, thank you guys. It was quite interesting for me. I hope
Yeah.
for everyone else. Thank you so much. We can have a couple of minutes, like 5 minutes break. So we come back 7:47. Okay, to continue with the second team. Basically, it will be Fernanda, Alejandra, and Brian.
Okay, thank you.
Yes.
Okay, so you can go ahead, share your screen.
It's Fernando's presentation. It was a bit bad day for
No,
being in the same
No.
presentation.
don't worry. In this case. I don't want to. I want to split all the screen. Do you see everything or?
Now we see when you present
Yes.
the slideshow, then we see just your slides.
Ah, this is the one I was looking for because I don't like when it takes all the screen.
No, actually we
Okay.
see your browser.
When you see the
Tabs.
header of the browser,
Yeah.
You also see this part. Here's okay.
Yeah, it's okay.
Okay. So you first, Sandy?
Yes. Hello, today we are going to talk about Lambda. I know you already heard some things about Lambda in the past presentations, but we are going to try to go more deeply and explain you a little bit more of what is Lambda and how it works. Can you go next, Fernanda, please? Okay, when you are building applications as a developer, you want users to have an excellent user experience. And to make this happen, your applications need a backend that runs perfectly. So if developers want to manage the infrastructure and execute the backend code, requires to have a lot of servers, manage operative systems, apply security patches, monitor all the infrastructure for performance and availability. So this means that it requires a lot of work from developers, and these don't allow to developers only focusing on building apps. Can you go next, Fernanda, please? So the question is, will it be nice to focus only building great applications without having to worry about their infrastructure? And can you go? And that's why Amazon created Lambda. Can you? Okay. So what is Lambda? Lambda is a serverless compute service offered by Amazon. As I told you, I already explained you in the past in my past presentation what is serverless, and I know most of you already know what is serverless. And Lambda let you run your code without worrying about manage your servers. You can write your application or backend service using Lambda with zero administration. The code that runs in Lambda is called Lambda functions. Currently, it supports Java, Python, C#, Node, and other programming languages. Also, Lambda provides an API that can be used to run functions written in other programming languages. And with this, you can use any language that you want. Can you go next? What do you need to use Lambda? The only thing that you need is to have an account in Amazon from where you can access the management console of Lambda. So how does Lambda work? The way it works is that you only have to allow your code in a zip file, or you can write your code directly in the management console of Lambda. You can write this code, as I told you, in any language supported by Lambda. Another thing you can do is that in Lambda, there is a list of functions with the most common use cases, and you can select one of these functions. The next thing is that once your function or your zip file is uploaded, there will be some services that will allow you to trigger your function. For example, the ones that you see here. Actually, the courses that Maddie told us to take, in those courses, they explain you all of these services. I already took some of them and are very interesting and very easy to understand how it works, each service. The way that Lambda handles the cost of service is that you only pay when Lambda code executes. And here is a list of the things that, for the things that you have to pay. So can you go next, Fernanda? What makes Lambda a key part of the serverless architecture is that, as I told you before, when we talk about building applications without managing servers, Lambda is one of the best options. It is one of the primary compute services right now because you can use any language that you want, as I told you. And it's very popular because you have a complete serverless stack. You have a computational service, database service, and HTTP gateway service.
So now let's talk a little bit, sorry, with the strong arm of Lambda, that is task automatization or automation. Automation is something with a lot of imagination, can be implemented in almost every sector. The most common being the 4.0 industry, but also in other sectors like food, health, and manufacturing. But of course, right now it's implemented more like in big data, Internet of Things, or even cybersecurity. So many different companies use Lambda, obviously, to save time / money in repetitive processes. And actually, it's very good at it. Using Lambda reduces operational cost a lot. And we will show you I will show you some examples of this later. Things such as the updation of hardware devices, the start and stop of Amazon EC2 instances, the scheduling of security group updates, cleanups, tests, transferring or converting formats on demand, among others, are examples of things that can be automated. And although Amazon always defines themselves or sells themselves with the motto of easily update your IT processes so you can focus in writing better business logic, well, I think behind this are more advantages. So I will show you at least 5 of the most notorious benefits of Lambda, so you can determine if Lambda suits your company or your project. So let's begin with the first one. It minimizes cost, as I said. I know we already said this a lot, but it indeed one of the biggest advantages of Lambda, but we need to understand why. It's not pure magic. Lambda use the pay-as-you-go model. Well, it use this model. This means you just pay only for what you use. So none of the money you pay at the end of the month goes towards any unused service time. This way you indeed minimize a lot of the operational cost. big and small companies have reported massive savings of after going serverless in the first month with Lambda. One example of this, it's this big company called Heavy Weather. I never heard about this, but apparently it's one of the biggest companies that use artificial intelligence to give like financial services to other companies. And basically they cut their monthly bill from 30,000 to 4,000 the very same month they moved to Lambda. This is like, it's not like, it's 87% of the cost reduction. And as you know, there is a myth that says that this kind of like big impacts in money, it's only perceived like in big companies, because if you have a lot of money, well, tiny changes will be really impactful. But there is another example of a small business, and I think it's the creator of this company, it's called Abner Sorek, if I'm not pronouncing that incorrectly. He creates Envo. He provides service and cloud deployments to other companies. Well, basically he applies cloud computing to some process of other companies, and it's just him and like other friends. And basically in the first month they cut from, I think, 44 a month to 6 a month. I know it looks like tiny money, but it's also the 85% of cost reduction, and save some money. It's better than not save money at all. And this kind of savings can be a pretty good beginning in your small business. So it's pretty good. Benefit number 2, automatic scalability. Let's say that for some reason, I'm sorry for the super bad Photoshop. Let's say for some reason, your application suddenly goes viral and you never know what happened. Maybe Elon Musk tweets about you and your application gets overloaded with thousands of service requests. Although that it's a nice problem to have, it's still a problem because, well, you need to upgrade your capacity to receive all those messages without crash your own system. But with Lambda, the application scales automatically. It doesn't matter if it needs like, if it passes for 3 requests to 2,000 requests the next day. The very nature of serverless accommodates all its resources to cover these spikes of usage. So it's very nice. Benefit number 3, it's a killer of use cases. Lambda already has variety of use cases well covered, and they even have templates that you can use for such cases. For example, daily tasks. It's basically a Python library employed to accomplish basic daily functions such as report or make backups of your information, also notifications, any type of notification, particularly real time. Basically, once you create your SNS, you can set triggers that will fire under certain policies or circumstances, so it will show users notifications. Process S3 objects, and well, probably the one I think I still need a lot of work, chatbots. Automated chatbots make for excellent Lambda use cases. And there's a lot of templates that you already can use, but they still need a lot of work because they still feels very robotic. It's very different than chatbots that only told you like, okay, if you're searching for this is like an index of responses instead of intelligently respond you. But yeah. Benefit number 4, more than 50 company service. 50 service that Amazon already has. Amazon has over 50 different services in Amazon Web Services, and a clear benefit of being a monster that Amazon is, they offer native compatibility between its many different platforms and services. And a quick example about this, let's say you want to start a project or a company. Let's say you want to start a cleaning robot company. So you do a simulation of this robot with Robot Maker, that is this one. Also, why not? IoT is very popular. So let's say that you want to start to collecting some data from your users to start mapping their houses remotely and give it some updates. Well, you can do that. You can do that with IoT core. Sorry, but you know what? It could be even better to automate these updates. Obviously using Lambda. And why not? You don't even need to write your own code because Amazon also has this called reportless repo. Sorry, that is basically a repo that with a lot of templates and pre-made code that you just download. I mean, you just look for, I don't know, cleaning robots, and probably someone already created a program that it will give the intelligent part to your robot. So you don't even need to code any part of this for his spaces. And yeah, that's how you basically create a big company that now you can pitch to Shark Tank. With zero effort, just like Googling about the services of Amazon. And final but not least, it supports common programming languages right now. It just covers, I think, Python, Go, Java. They're working to implement also Ruby and JavaScript and many other language programs, but at least they cover the most common ones. That is Node, Python, Ruby, Java, Go, and .NET, but they're still working on implementing more languages. These are the most basic ones, but they will in the future cover more languages. They're still working on this. And yeah, those are the 5 benefits that could suit your company pretty well. And yeah, Brian, I think it's this part.
Yeah.
Okay.
Well, for challenges and solutions, well, when it comes to monitoring and logging applications in Lambda, well, it's true that we cannot rely directly on background tools to continuously monitor a web server. That's why I want to show the 3 different challenges that there exist. And first, it's the debugging. It's hard to debug on Lambda functions for the 3 main reasons. The first is like the logs are in different locations. So when you want to find the root cause of your problems or your main issue, it's difficult to locate it by using Lambda. And well, that's why they recommend most of the time to use a second service called AWS CloudWatch logs. But some people say it's kind of difficult to use. I haven't used it, so I don't have experience. Also, a second challenge to work or to understand with Lambda, it's the avoiding timeouts. It's a common problem to face unexpected timeouts. So there exists the API gateway related timeouts, and also the call low memory timeouts, where they said, okay, most of the invocations they don't consume the same quantity of memory, which is why you should set an accurate size of memory. But this is kind of tricky most of the time, and Amazon provides like 4 solutions. The first, they said, oh, disable the use default timeout. So just use a different one or set a different one. Try to use the CloudWatch alerts, and also increase allocated memory. It's like, okay, you don't have enough memory, so increase it. It's not the best solution. Could you go to the next one, please? And well, they recommend, or Amazon recommends to services that are called Amazon CloudWatch or AWS X-Ray. And these 2 services provide partial solutions to the challenges. The 3 ones are monitoring, logging, and tracing. The first, Amazon CloudWatch, just to give a small summary about it, it's that it collects operational data in the form of logs, metrics, and events. And the plus that Amazon CloudWatch gives is that you can see the this information by using automated dashboards. So you can see all your AWS resources and application in just one service. It's like you can see a summary of everything. Also, you can create alarms, and you can see anomalous behavior of what you're doing in general. So that's why Amazon CloudWatch does. And also we have AWS X-Ray. The main idea here is to gather trace information such latencies, HTTP statuses, and metadata. So with this information, we can identify the root issue or problem. Then in the next slide, I want to show the comparison of this. The next one, please. Sorry.
I don't know
Well,
what I mean.
here we have a comparison between AWS Lambda and AWS EC2. While researching, we saw that they compared them. So, well, as we said, well, first, AWS Lambda, it's a platform as a service, and EC2 is just, it works as infrastructure as a service. Both of them, well, first, EC2 offers more flexibility than AWS Lambda, even when we can have a customized operating system on our AWS Lambda, but we can do it on EC2. It's like, well, as I said, it's more flexible, right? So then in installation process, it's almost the same. We need to select, we need to choose our operating system and also install all the required software that we need. And with restrictions, the main difference is that AWS Lambda is restricted to a few languages, while EC2, it doesn't have environment restrictions. Can we go to the next one, please? Okay, then we have a AWS Lambda versus Beanstalk. I think it's pronunciation. Well, the first main task of Lambda, as we have said during all the presentation, is to running and executing the backend code. And with Beanstalk, we can manage all the apps on the AWS cloud. We don't need to worry about infrastructure, so it's gold from Beanstalk, and also from the selection of the resources. With Lambda, we got freedom, so we can choose EC2 instance, which is optimal according to the application. And with Beanstalk, we cannot select AWS resources, like for example, an EC2. So it's a big difference. And with the type of system, Lambda is a stateful system, while Beanstalk is a stateless system. And well, the next slide, please. Well, here I think it's we don't need to assess our summary. We select the 5 points, but we can say that with Lambda, we don't need to worry about which AWS resources to launch or how AWS will manage them, or Amazon will manage them. So then we can say that AWS Lambda is not suitable for small projects. So you're thinking about it, please think it twice. And well, most of the other points we have talked about them overall the presentation. So I think that's all from our side. And thank you.
Thank you.
Okay, guys, thank you for the presentation. Any questions from the class?
It was so clear. Thanks a lot.
Is there anyone here have experience using Lambda?
I have a question.
Go ahead.
I've never used these kind of services. What if can you ask for specific type of hardware, for example? I don't know, CPU frequencies or memory frequencies, or is it only that you have a serverless environment and that's it? Or how specific can you be when you request this kind of services, for example, AWS? Did I explain myself or not? For example, you do a request for a service, right? I don't know. I've never used any of these services before until now. This class, I have been knowing what is this service is about, but what I understand is that you rent like serverless environment for X amount of time. Am I correct?
I think that, as I told you, it has a lot of services, but the way it works is that you say like, I want to have like 5 servers, but it's different kind of services. For example, you can use it like database to save your files or something like that, or you can use it for your applications. It has a lot of services, but I don't know if I answered your question, but
the first question, yes, but the second question, and my real question is, for example, let's say you have an application that performance application that performance matters. Are you able to ask AWS? I don't know, top bin CPUs or better hardware, for example?
Actually, I don't remember the names right now, but for example, as I told you, it had different services, and there are for example, if you say like, my applications is going to be used by 1,000 people or for 1 million people, it recommends you what kind of servers or service you have to use. I mean, like, there are for example, if your application is for the government and maybe you need more security, it will recommend you another service. I mean, like, it depends on the capacity you need, or the privacy or things like that are different kind of services. I mean, like, it's not only one. Or I answer your question or not?
Yeah, and at the end, it makes sense because serverless, so that means that you don't need to be worried about, but they only provide the service that you need. Okay. But I was
yes,
asking
and that's why it's very popular, because it has for all types of applications or database that you will need. For example, if you need like a lot of, for example, YouTube, if you have a lot of videos, it will give you like another service where you can pay less because they know that you are going to use a lot of memory. So yes, that's the way it works.
Okay, thank you.
Any other questions? No. Okay, guys, thank you for the presentation. So let's have another 5 minutes break, just to stretch, drink something, and we continue by 8:22. Okay.
Yes, thank you.
Okay, with the last presentation. Okay, guys, if you're ready, you can start sharing your presentation.
Can you see my screen?
Yes.
Okay. Hey, everyone. So we're going to talk to you about SOLAS. Okay. So first, I would like to introduce one pattern that is kind of new, and it is called event-driven architecture. So basically, event-driven architecture is a software design pattern, right? What can you do with it? You can decouple applications, and those applications can publish and subscribe to events via an event broker, right? What is an event? Well, an event is all the things that happen within your enterprise, like a user request, clicking a button, a software update, meaning the changing state of an object in your system, or for example, in IoT, it could be also considered as a change in state for the IoT devices, right? All of those are events. And what is an event broker? Event broker is the software, and its function is to transmit those events or messages between the producers and consumers as using publish subscribe pattern, right? So in the image, we can see that we have like circles, and those are producers. Those producers communicate with the event broker, sending the events or messages, and the event broker job is to send those messages to the corresponding consumers. So that's just a little bit of what event-driven architecture is. And this is where SOLAS comes in. What is SOLAS PubSub platform? Well, SOLAS, it is an event broker, right? It is an event streaming and management platform, and it streams events and information across cloud, on-premises, and IoT environments. So basically, it sends messages to the cloud, and what I say, right? Sorry. So SOLAS PubSub, it is available as an appliance, hardware. It can be also software, and it is also a cloud offering. You can find it in AWS, Azure, and Google Cloud. So basically, in the image, we can see just one representation, right? These circles are the event brokers, and the event broker's job is just to send messages, and yeah, on premises, cloud, and etc. So sorry. The main components of SOLAS PubSub can be summarized in like four components, right? One is the event streaming component that gives you all the functionality for event broker, all the services. I'm going to talk about a little bit later, actually in the next slide. Event management provides event manager services like to create, design, share, and manage those services. The event insights provide dashboards to visualize how your messages are either doing, visualize historic data, and real-time analytics and metrics. And one fourth thing is the platform security and the APIs that SOLAS can provide. So I think personally the most interesting thing is this event streaming. The event streaming is basically the functionality that sends the messages or events, right? It gives you four, are more, but these are like the most important, let's say. It provides you features like the publish subscribe message pattern, queuing, reply, and request reply functionality. I'm going to talk a little bit more about this later. Also, it provides protocols, several protocols like REST with HTTP, MQTT, and MQP, like for IoT, and also this it provides APIs with a lot of for a lot of programming languages. So this is just a visual representation of all the things that SOLAS has. Like SOLAS is in the middle, is in the broker, but all the applications using, for example, protocols MQTT, AMQP, HTTP can connect to SOLAS with different languages. Also, there are it has connectors for specific software, for example, Kafka, Oracle databases, more databases, Snowflake, etc. Right? So yeah, it has a broad variety of connectors and APIs. So, and as I mentioned, Solus is an event broker. It is the main feature, and one of the key components in Solus are Solus topics. Well, actually, it is not just for Solus, right? It is for every event broker. It has topics, and the topics is basically, in Solus at least, is just one string. So it has a hierarchical structure to classify the messages that are being sent for the publishers. And yeah, they look like this. They are divided in levels, right? We have level 1, level 2, level 3, and level 7. In this specific case, you don't have a limit in the level of in the number of levels that you can create for the topic. For example, this is how it will look. Right? In the example, we can see that this topic structure is for a payment application, probably, and stage init, and country MX, version B1, channel credit card, BBA, and Uber. This means, for example, that one application can send messages with this topic structure, and other application, for example, could read those messages. For example, if one subscriber application is interested in knowing all the purchases probably in init stage for MX, they could subscribe to this, right? We're going to see that one of the key features in Solus topics is that we have wildcards, the asterisk wildcard and the greater than wildcard that provides a lot of functionality. Some of the characteristics of the Solus topics is that they are case sensitive, right? Here is a little example of the pay, that pay dash init is different than pay with uppercase dash init. They have 250 characters max length, and they support wildcards. So this is the use of wildcards. It means that you can, well, again, sorry. So this is the published topic, right? One publisher application is using the topic system status +1 statistics. So if these two are valid topics subscribed, these two are valid topics, sorry. What this first means is that the subscriber is interested in any message that has this structure, that the first level is system, the second is status, and it doesn't care about the host that is sending the message, right? But in the fourth level, there has to be a statistic string, and that, and yeah, those all messages sent to this topic are going to be sent to that subscriber. In the second case, we have something similar. We have that the subscriber is interested in the in messages where the first level, topic level is system, then the second is status, and then there is a string host, and it doesn't care about the number of the host that is sending that message. And then the fourth level has to be statistics, and yeah. We have other examples that are incorrect in Solus. In this case, for example, in the fourth level, we have system status +1 statistics, but the subscriber is not going to get any message from the publish because the asterisk is in the fifth level. So yeah, it is going to get messages, but only if the publisher is sending messages to at this level, right? This is incorrect just because the asterisk wildcard is at the beginning. And we have the greater than wildcard that is used at level. So basically, it means that you care about some levels in the topic. Like in this first example, for example, one subscriber application is interested in topics that start with system. The second level is status. The third level is host 1, and you don't care about any other level, right? It could be many levels in depth here, and all those messages are going to get to that subscriber, to all the subscribers using this topic. Something similar here, but now for just level 1 and level 2, and you don't care about any other. So this, for example, all the messages that all the subscribers are getting here are going to be encapsulated here. So how does it work? Yeah, it's similarly to Kafka. Solaz is also an event broker. So basically, well, mainly its job is to send messages to the subscribers, right? Publishers send messages, and a message looks like this. It contains a header, a topic, as we saw before, like this. And it contains the body. The payload could be a JSON, a text string, an XML, anything, right? Just it's a payload. And the Solaz broker reads the topic, and it has a list of all the subscribers that are subscribed to a specific topic, right? In the example, for example, we can see that these two publishers, probably just one, well, anyway, these two publishers published 5 messages, one with topic A, two messages with topic A, 2 messages with topic B, and 1 with C, right? The subscribers, the first subscriber is just interested in messages with topic A, and the second subscriber is interested in topic A, B, and C. So Solaz is going to take care of sending to the first subscriber only messages with topic A. And also Solaz is going to take care of sending all the messages that with topic A, B, and C. So these 3 will go to the second subscriber as well. The difference with Kafka is that Kafka works with logs, with topics. Every topic is basically a log file. And when there is a message, there is basically you are writing at the end of the log file. In the case of Solaz, it is different. It is defined as a subscription matching engine where it just it has a list of the subscribers and the specific topics, and yeah, the engine just takes care of sending those messages to the subscribers. Other difference is that in the case of Kafka, it has a pull mechanism. So all the subscribers read from Kafka, and in Solaz, the difference is that Solaz sends those updates, sends those messages to every subscriber. Also, Solaz has like different message exchange patterns. These are like kind of the more important. I think there are some more, but these are like the important ones. It supports the publish subscribe. Basically, a publisher sends a message to Solaz, and Solaz takes care of sending that message to all the subscribers for that topic. The point-to-point, the producer sends a message to Solaz. Solaz takes care of sending that message to the consumer. Request reply, the producer sends a message to Solaz, and Solaz sends that message to the consumer. And then the consumer, once having the response, sends the response to Solaz, and Solaz sends the response to the producer, to the original producers. And in the case of Q, it is very similar to publish subscribe, but the producer sends a message to a queue in Solaz, and then Solaz takes care to send that message to all the subscribers, to all the subscribers or consumers. One important point here is that Solaz has what is called an event mesh. Basically, it is the combination of 2 or more event brokers that share messages between them. So in the image, we can see that there is like 3 cloud using Solaz brokers, and every cloud has its own like features, logic, and stuff, right? But every Solus broker is connected between them. So all the messages in one cloud are going to be sent to other clouds or on premises. And also the IoT can send messages to Solus, and Solus takes care of sending those messages to all the event brokers. So that's what's called event mesh. And I think that's pretty much it in the event broker side. Would you like to continue, Charlie?
Yes, sure. Hi, everyone. I'm going to talk about the rest of the Solus components. So the component that Solus offers for Event Insights is called PubSub Insights. It enables teams to ensure the system health basically by ensuring the event broker service and the event mesh infrastructure are available and ready for use. And it offers at a glance a status of various aspects such as resource usage, event mesh health, message flow, capacity utilization, high availability status, queue, topic, endpoint, RDP, and bridge health, and also message pool utilization. The main idea behind PubSub Insights is that the team always know what's happening with their event infrastructure. So to achieve this, the tool provides hundreds of real-time and historical metrics for your event broker services, plus logs to help to analyze, debug, or troubleshoot your applications, and also probably to improve performance and those kind of things. Can you go to the next slide, please? Okay. So also the Insights tool helps to understand the health of your event broker services thanks to these utilities included in the tool that are the in-console overview that allow to quickly see the key performance metrics for each event broker service. Also, we have the account-wide stats that provide at a glance view of your messaging state. And the tool also comes with some pre-built advanced dashboards that allow deeper analysis on the health of the system. So in summary, the benefits of this component is that it allows teams to detect potential issues before they have a negative impact in the customer. Also, they allow to recover quickly with a real-time alerts and dashboards. And finally, to monitor performance for optimization and capacity planning. The next call that Solus has is for event management and is called PubSub Event Portal. And could you go to the next slide, please? This tool enables team to discover and understand easily the existing architecture of all of your applications and events, also to control your event data, to catalog events, topics, and data like APIs, to quickly develop consistent event-driven applications, curate and share sets of high-value events with internal and external developers to reuse, and to analyze dependencies between applications and microservices. All this in a very intuitive UI. So how users would interact with Event Portal? For example, the architects will discover, create, update, and review apps, events, and payload schemas. Also, they would map payload schemas to events and events to applications, and they would probably govern event consumption across the application. And developers will collaborate with architects on the design of the whole system and generate and implement event-driven applications. Data scientists could use the tool to understand event-driven data and to discover new insights by combining events. Okay, the tool, the event portal tool comes with 3 main utilities that are the event designer, event catalog, and event discovery. And we're going to go through each of them. The event designer allows developer to visualize, design, and code event-driven applications in an intuitive UI. So from this UI, you can easily add applications, events, and schemas, and create relationships within them. For example, this is a graph view. Could you go to the next slide, please? So this is a graph view of the tool. We have here applications and the events that are related to those applications and how they flow within the system. The tool also comes with a step-by-step guidance included that makes it easier and faster to create and define relationships between applications, events, and payload schemas. And the next tool is the event catalog. The event catalog allows us to promote, find, use, and reuse events and schemas by different applications across the enterprise. So we can browse all our events and use it or use them in our applications. It also allows to ingest events and schemas from any commercial or open source event broker. So here we see in this image that we can see like a view of our whole choreography of our system. So event discovery makes it possible to visualize, understand, and manage history, usage, health, and security of the events in our system, and also to audit runtimes for deviations in the design. And it includes a topic hierarchy explorer that it's basically a graph that allows us to view the events in a with hierarchy, we could say. So for example, the center is the root and each ring is a level in the system.
Yeah, hello. I'm going to talk about the security APIs and additional features and customer use cases. Solaz provides an API for message for different interfaces to help developers to communicate with the message bus. So PubSub Plus broker. Those are the provides APIs. Can you go to the next slide, please? This list shows the feature availability feature available in the API. The API evolved to meet the use cases required for client application. So there are slight differences in the features supported depending on the language to use. So you need to select the message app API that's right for your requirements. The message API use processing context for organizing communication between an application and as well as event broker. So a context encapsulates threads that drive network I/O and message delivery notification for the stations. And the stations are encapsulates all services and functions available to a message bus client like browser, cache session, and flow. Continue with a session. A session creates a single client connection to an event broker for sending and receiving messages. And sessions also allow applications to add or remove subscriptions. For example, the client has the power to add or remove subscriptions in sending for the topic of subscription, like we see in the graphic. And also the client can publish messages for destinations, and also can be a topic. And a flow is an object of the API that allows application to receive guaranteed messages from an endpoint, such as a queue, and it's created by a SOLAS session. For the security, this is an overview of security of PubSub Plus and event brokers. So the goals for achieving secure systems are restricting data access, preventing data loss or damage, role separation, and establishing audit trails. These goals can be achieved through secure system capabilities, such as common ones using in the industry, authentication, authorization, auditing, and encryption. Authentication are the credentials for the first connection message to the broker, to a subscriber. The content will be the username and authorization credentials. And if the broker receive valid credentials, a secure session is established. And for the authorization, the user needs a different levels of authorizations. And for example, those authorizations are for connect, to consume resources, to send and receive data, and change system properties. And for audit, to ensure that the system authenticates and authorizes the right individuals, the system must be self-monitoring and logging events. So all the events for the configuration changes, data access, and for example, security issues like forcing a password will be logging in the SOLAS database. Another important aspect is that the messages are encrypted in closed systems where the producers and the consumers of data are managed by one entity. The security requirements are homogeneous across all the producers and consumers. So the data should be encrypted as close as possible. And the application team's owners will manage the encryption keys, but in a more open system where it may not be practical for our consumers and producers to share the encryption keys or have the same level of security. The best option is to encrypt only the following areas, like the administration connections, network encryption between brokers and clients, encryption of bridges and messages routing for the exit of the messages for an open internet access, and encryption of the disk and data. The rest are not the encryption of data that is not being transmitted is not done by Solus, but Solus has the ability to request to the cloud or to the service we are doing the broker. So the data that is encrypted, it's only the data that it's being transmitted in the network. Some benefits of from compared to competitors are, for example, plans for you have access to a limited features, but you can also pay and deploy and scale your system easily. So there is a plan for 10,000 messages a second. That is a lot. So many small companies have access to those services, and you have a very wide service prepared for different clouds or different platforms to enable the event broker. In the next slide, and also PubSub Plus, the Solus broker. It's an integrated platform. As we see before, we have many windows to monitoring, and it is easy to manage, and also because you have a lot of tools and portals to accommodate the system to your preferences. So who is using Solus? Those are some customers. There are a lot in the page, but for example, it's Grupo Versátil Mexicano, Renault, Heineken, RBC, London Stock Exchange, SAP, Unibank, and in the next slide, some use cases. For example, RBC, that is capital markets. they use Solaz to send messages in the volume of 1.3 million messages a second. So there's a lot of volume. It's also almost the limit of the Solaz application. I think it's 1.5 million messages a second for a single application. So there's a lot. And for example, NOAA, this is a partner with NASA. There are weather satellites, so disseminates information from the satellites to agency and organizations that use the information to track and predict the weather around the world. I think that's all for our part.
And thank you guys for the presentation. Any question from the class? Nothing. Okay. Everyone apparently is tired. They just want to go and have dinner, probably. I mean, you didn't talk about that money things. I mean, did you read anything about that, about the business side of it?
Well, I tried, but yeah, I had to contact sales support, the sales representative. It is not a open source project. It is, yeah, it costs. Yeah, I don't know about like the prices.
I mean, you included in the last slide that they had one free version, one enterprise version, and the free version is like free. Enterprise version is the one, probably the companies that you mentioned are using. But is it open source or?
No, it is not.
It's not.
No, it's not.
So it's obvious how they make money. Okay. Okay, thank you guys. Thank you for the presentation. We are done with the deep dives. Please include the presentation in the Google Sheet. Also, Team Pedro, you haven't also included, Pedro, Christian, Paul, the presentation about Kafka. Please include the presentation file in the Google Sheet so everyone can have access to. And yeah, that's it. Have a nice night, everyone. See you guys next week.
Just a reminder, we need to upload the resumes, right?
Yeah. The summaries, I don't remember the deadline, but should be
Sunday.
Okay. Yeah, by Sunday. All good? Any other question? Okay. Have a nice night.
Thank you, Marie.
Thank you, you too.
Take care.
Bye.
See you guys.
Bye.
Thank you.